am Dr. Tarun Sharma, HOD Department of Science in Bionic Group of Colleges. Today we will discuss the partial differential equation. Earlier we have also discussed some kind of definition and few related examples of partial differential equation. What is variables, what is dependent variable, what is independent variable. Now we will extend our previous lecture while taking some important question which is asked in the examination. How we will deal this equation? We will solve one by one. For the first question, we will take as if u is a function of x square y plus y square z plus z square x. It is a function in three variables x, y and z, and we are to ask then show that del u by del x plus del u by del y plus del u by del z is nothing, it is x plus y plus z whole square. It's very easy question and many times it is asked in the many competition examination and university examination of b.sc courses. So how we will discuss solution? We are given u x square y plus y square z plus z square x. Let us give this relation 1. Here we have observed that u is a function in x, y and z. We can say that u is a dependent variable x, y and z independent variable. So let us take one by one now. Differentiating 1 partially with respect to x. So what we have? F of x del u by del x del by del x, and this is x square y plus y square z plus z square x. So it is nothing, it is notation f of x del u by del x, and it will become 2 of xy plus 0 plus z square. Here we observe that y is a constant, therefore it remains same, and partial differentiation of x square is 2x. Here what we observe, y square z is the other two variable which is taken as a constant, therefore derivative of partial derivative of this variables will be 0, and here x is derivative of x is 1 and z remain the constant, therefore z square dot 1. Hence we have f of x is nothing, it is del u by del x 2xy plus z square. It is the first derivative of function u with respect to x. Similarly, we can find del u by del y. Let's keep here, let's write f of x here. F of x is equal to del u by del x 2xy plus z square. Now differentiating 1 partially with respect to y, we get del u by del y f of y del by del y, and this is x square y square z plus z square x. So f of y del u by del y, so we have x square plus 2yz plus 0, because the x square is constant, therefore it remains same, and partial differentiation of y is 1. Here y square differentiation of partial differentiation of y square is 2y and z remains same, and finally z and x is the other two variable, other independent variable, therefore they will be taken as a constant and the derivative will become 0. Thus we have f of y del u del y is nothing, it is 2yz plus x square. This is f of y. So we will put here f of y del u by del y, it is 2yz plus x square. And finally we actually we have already obtained del u by del x, del u by del y. Now we need to find del u by del z, means we need to find derivative of function u with respect to z. So how we will proceed? As we already proceed in the f of x and f of y. So now differentiating one partially with respect to z only, we get f of z del u by del z is equal to del by del z, and this is x square y plus y square z plus z square x, and f of z del u by del z. So derivative of this function with respect to z will become, this is 0 plus y square plus 2zx. So we have f of z del u by del z is nothing, it is 2zx plus y square. This is f of z, derivative of function u with respect to z. Hence we have f of z del u by del z 2zx plus y square. So we have obtained del u by del x, del u by del y and del u by del z one by one, and these are written as like this. Now what is remaining? Just we have to add these relation. Now adding these, we get, what do we get? We get f of x plus f of y plus f of z, that is del u by del x plus del u by del y plus del u by del z. And what is this? This is nothing, this is 2xy plus z square plus 2zx 2yz plus x square and plus 2zx plus y square, and keeping in some standard manner, x square plus y square plus z square plus 2 of xy, 2 of yz plus 2 of zx, and it is nothing, it is x plus y plus z whole square. It is a formula of algebra, x plus y plus z square. Hence we have del u by del x plus del u by del y plus del u by del z, and this is x plus y plus z whole square. Hence proof. So you have observed that this is very easy to find the partial differentiation of the given function. Here it is a suitable example of 3 variable. We have more than 3 variable also, but when we discuss about the 3 variable, then we can take this example. So we are asked to prove that del u by del x plus del u by del y plus del u by del z is equal to this. So already we are given the solution, we just need to prove it, and we have already proved by using the following steps, and this is our required result. For the next example, we will discuss, suppose that we have given if u is equal to natural log of x square plus y square. Find number 1 del u by del x, number 2 del u by del y. So it is a very MCQs type of question. So how we will solve? Let solution. We are given function u is nothing, u is natural log of x square plus y square. This is number 1. Now differentiating 1 partially with respect to x, we get f of x del u by del x, del by del x, and this is log of x square plus y square. So it is f of x del u by del x, and you know that the differentiation of log x is nothing 1 by x, therefore it will be treated as 1 upon x square plus y square, and by applying chain rule we have 2x plus 0, therefore we have 2x upon x square plus y square. So f of x del u by del x is nothing, it is 2x upon x square plus y square. It is the first derivative of given function. Similarly, we can find del u by del y. So for finding the derivative of u with respect to y, we will partially differentiate 1 with respect to y, and it will provide as f of y del u by del y. So del by del y log of x square plus y square. So it will be f of y del u by del y, and it will become 1 upon x square plus y square due to log of. We will treat is like a single function log of x, and derivative of log of x is nothing, it is 1 by x, and by applying the chain rule, the derivative of x square is 2x, and derivative of y is, the derivative of x is 0 because we are differentiating partially with respect to y, therefore derivative of x square is 0, and derivative of y square is nothing, it is 2y. Therefore we have f of y del u by del y, it is 2 of y upon x square plus y square. It is suitable example of differentiation of function u with respect to y. So we have f of y is nothing, del u by del y is equal to 2y upon x square plus y square. It is the MCQ type question which is asked in the many examination. For the now we will take one more example for understanding the operator property and understanding the operation of partial differential equation. So let us take if u is a function of x to the power of y, if u is a function of x to the power of y, then find number 1 del u by del x and number 2 del u by del y. It's a very easy question. So for the solution, we are given u is a function of x to the power y. For the solution of this kind of function, we will take logarithm both sides. So taking log both sides, we get log of u log of x to the power y, and this is nothing, this is y log of x. This is number 2. Now differentiating 2 partially with respect to x, we get differentiation of log u will become 1 by u, and derivative of u is del u by del x, and y is a constant. Differentiation of log x is 1 upon x plus log of s it is, and differentiation of y is 0. Therefore, it will become y by x. So, del u by del y is nothing. We will multiply u from that side, then it will become y upon x u, and u is what? X to the power y. So, y upon x into x to the power y. It is a derivative of del u by del y of the function u is to the power x to the power y. Let us check the answer. So, x to the power y upon x. Yeah, absolutely true. Similarly, we can find the derivative of del u by del y, derivative of function u with respect to y. So, it is also easy. The procedure will be remain same. So, again we are given u is nothing x to the power y. This is number 1. Taking log both side, we get log of u is nothing, it is log of x to the power, and it will become y log of x. So, it is number 2, or we can say it is number 3. Now, differentiating third partially with respect to y, we get, so derivative of log u is nothing, it is 1 by u del u by del y, and derivative y is 1, or we can say del u by del y, this is y log of x, and it will become derivative y is 1 log x constant plus, and y is it is derivative log x is 0, therefore it will become only log of x. So, while putting the u from the right side, we have del u by del y u into log of x, and what is u? U is the value of x to the power y, therefore x to the power y into log of x. So, del u by del y is nothing x to the power y log of x. It is required result. So, students, you observe that the finding the derivative of any given function, it's quite easy if we have the knowledge of dependent and independent variable and the operator. So, in this class we have discussed the few example which is related to partial differential equation. In the next lecture we will extend the present lecture by taking the more complicated problem of partial differential equation. Thank you very much for watching this video. Please like, subscribe and share this video, and don't forget to watch our educational video on Guru KPO channel. Thank you very much.